Okay, for our second video on inequalities, we're just going to take a look at what happens when Desmos graphs an inequality. When we graph them, what happens, what's different from the regular line. So there's our line of y is equal to 2x plus 3. We can plot it by finding some x and y intercepts or some points. But when we do it with an inequality sign, and you've got to get reasonably familiar with these signs. This is y is greater than or equal to 2x plus 3. We get this kind of thing happening. Not just a line, but now we get all this shading. Now we need to understand what the shading means. And basically the shading, without the shading, this line, any point on this line, 0, 3, if we stick it in 0 for x and 3 in for y, we get basically this side of the equation equal to this side of the equation. If we stick in negative 1.5 and 0 in for x and y, we get the left-hand side equal to the right-hand side. So we can stick any point in here. It's nice if you have exact points and so on, but and that will hold true, but only points on this line hold true for this equation. But when we have a greater than or equal sign, y can be greater than or equal to 2x plus 3. Now we not only have the points basically on this line that work, but we have all these points over here. So we can stick a point anywhere in this area, negative 4 and 2, and we can stick that in. So if we stick in 2 for x, we get 4 plus 3 is 7. Negative 4 for x. So we get negative 4 times 2, which is negative 8, plus 3, that gives me negative 5. And 2 in for y, and 2 is going to be greater than negative 5. So any point that I stick into this equation, so negative 2 for x is going to give me a negative 1 on this side, and so 4 for y, 4 is greater than or equal to negative 1. So any point in this shaded area is going to work for this equation. So there's infinite solutions to this problem over on this side of the equation. And that's what it means to, and that's why we shade, because we're showing all the possible solutions to this inequality, y is greater than or equal to 2x plus 3. And that's just what Desmos does, and it doesn't matter what you put in there. If I put in, or y is less than, I'm going to put in less than. You can sort of start to see some patterns here. Then negative 2x plus 3. You can start to see some things. So this was this equation, y is greater than or equal to 2x plus 3, and then we've got this equation where you've got the solution now is down in here. So all these points that you see work for and make this statement true. So if you plug in negative 2 for x and you plug in 2 for y, you can see that this is in fact true. Y will be less than or equal to this side of the equation. So that's it. And it used to be that you had to decide what side of the line to shade and all that stuff, but with Desmos it does it for you. So it becomes a very, very easy thing to do. So now when we graph inequalities in our Walker book, we can know that Desmos is going to shade the side of the solution for us. Now we're going to talk about that a little bit later on when we get into feasible regions, but for now we'll just stick with that whole idea that we'll shade the solution side for the equation.